Okay, so ambiguous case of the sine rule means that if you use sine of 30 and sine 150, like we've got listed here, or sine 110 and sine 70, they both equal the same thing. So for example, sine 30 and sine 150 both equal 0.5. So this means that you can have two angles giving the same sine value. One is going to be the obtuse version and one's going to be the acute version. So you can see in this actual example here how you've got an obtuse angle and an acute angle, both produced by the same length sides. This triangle has the same length sides here and here. So they call this the ambiguous case of the sine rule. Basically just means like it could be either obtuse or acute. And you have to look at the example to spot which one it should be. Okay, you'll get two values and you have to be able to find out which one it is by looking at the diagram. So if we look at this example here, okay, what kind of angle is that? Obtuse or acute? Missing angle X. Obtuse. So remember, obtuse means bigger than 90 and acute smaller. So we're going to do sine rule on this and find out the value of X, and then we're going to make it either obtuse, or we're going to make it obtuse so to make sure it's the right size. So first of all, which version of sine rule should we use for this then? Should you put sine A on top or on the bottom for the fraction? On top. Alright, so you put your unknown on top. So you got sine A over A equals sine B over B. Okay, and obviously we got a label. So that's one pair there. I saw some of you labeling your diagram already, that's good. And here's your other pair there and there. So you've got sine 24 over 1.9 equals sine of the missing angle X over 18.7. What do you do next? Yeah, times both sides by 18.7. So if we're going to do it properly, we should show it like this and show it cancelling out on the right. So you'll have 18.7 times sine 24 over 11.9 is equal to sine X. We're almost there. What do we need to do last so we have X as the subject of the formula? Inverse of it. Yeah, so we're going to do the inverse now of everything on the left here. So 18.7 sine 24 over 11.9 equals X. Now if we actually type that in the calculator, we'll check and see whether we're going to get the acute or the obtuse angle. So we've got inverse sine of, and then press Control divide, 18.7 times sine 24 over 11.9. Okay, so if we press Control Enter now, so we get a decimal number, we get 39.729, 39 degrees, 40 degrees. Does that look like it fits the triangle in the problem? Okay, 40 degrees would be far too small for an obtuse angle like that. Okay, obtuse angles have to be bigger than 90. So, how would we work out the obtuse version of this answer? So if I go back to the pairs, you can see that there's the same difference between these two numbers. What's the difference? So how have they worked out? If you get 30, how have they worked out 150? They've got 180, okay, which is effectively like a straight line, okay, and they've taken away the 30, yeah, to give 150. Same thing here, so they've got 180, and they've taken away the 70 to give 110, alright? So you can use the same procedure down here. So you're going to do, as your last line of working, 180 take 40 gives you 140 degrees. So that's the value of X, okay? X equals, says that there's two decimal places, so what did I miss off there? 0.7. 39.73, and then we'll do 180 take away 39.73, and we get 140.27. Okay. 24. Oh, to find this other angle? Yeah, you could do. I think they're just looking for x though in this question. But yeah, if you wanted to find this last angle, you just might.